Yeah. So good evening, everyone. Good evening. Let me know audio video okay or not. I think it is the place where we stopped yesterday. Check one time. Check one time audio video okay or not. Everyone check. Everyone check audio video okay or not. Small issue also there. Please let me know. Small issue also there. Please let me know. Can we go ahead? I hope is everything fine. Ella, can we go ahead? Yeah, perfect then. Audio video okay? Audio video okay? Yeah, tomorrow onwards on the EPT platform. Okay, tomorrow onwards on the EPT platform. Today is the last class, right? Yeah, let's start now. Everything is perfect. Let's start now. So yesterday we stopped here. Yesterday we stopped here. Yesterday we stopped here. Question number I think 116. Let's go to question number 117. Can you see this? Question number 117. It is a nice problem. Can you check once? Can you say what is the today's date? Please check what is the today's date. Yeah. So give me 1 minute. Give me 1 minute because the right. Yeah. I think a mouse. I can say pen. Pen having some issue. If I restart, mostly problem will solve. Give me 1 minute. So sorry for inconvenience. Now check. Is it okay? Audio video okay? Audio video okay? Now is it okay? Fine. Let me know. Please let me know. Sorry for inconvenience. Sometimes technology will go reverse. Yalla, can we go ahead? Anant, can we go ahead? Can we go ahead? Let me know audio video okay or not. Right? Yeah, this is the first problem. Sorry for inconvenience. Yeah, let me start this. Yeah, can you say what is the today's date? Is it 25? Today's date? Today's date is 25 or 24? 24. Yeah, today's date is 24. Today's date is 25, 24. I think everything is ready. Everything is ready. We can start now. Yeah, everything is ready. We can start now. I think Shiva is saying something, 6, 5, something like that. Shiva is saying. So can everyone try this? Today's class is just started now. 24, 10, 25. Yeah, can everyone start this? Can everyone try this? This is the first problem of today's class. Yeah, some inconvenience happened. I'm really sorry. Yeah, go ahead. Go ahead now. What is the answer of this? I will give the answer within few minutes. Yeah, please can you see this problem? Please can you see this problem and go ahead. I will give the answer within 1 or 2 minutes. Within 1 or 2 minutes, I will give answer. Please can you try this? Yeah. So let me give answer. I'm giving answer. Everyone see. Today's date is 24, 10, 25. Now I'm starting the class. Everything is ready. Now I'm starting the class. Please see everyone. So SLR1, LR1. LR1 means everyone remember CLR1. LR1 means CLR1. SLR1, LR1, LALR1. Right? For these three people, number of states are N1, N2, N3 respectively. N1, N2, N3 respectively. You know very well these two people are same. You know very well these two people are same. So N1, N3 always same. N1, N3 always same. Please try to understand. N1, N3 always same. Right? But we don't know about N2. N2 will be sometimes more. N2 will be sometimes more, sometimes equal also. So I think in the available option, if you observe clearly, N1 is equal to N3 is equal to N2, right? So this option and this option, these two options, one of the thing will be answer. Remember, N1 is equal to N3. First, N1 is equal to N3. N1 is equal to N3, okay. N1 is equal to N3, that is also okay. So this cannot be the answer. This cannot be the answer. So answer is either B or C. I'm going to explain how. Right? So remember everyone, SLR1 states, LALR1 states same. But we don't know CLR1, LALR1 same or not. Sometimes CLR1 is more. Sometimes CLR1 is more. Sometimes CLR1 is more, sometimes both are equal. CLR1, LALR1 equal. But every time SLR1, LALR1 equal. Every time N1 is equal to N3. No doubt at all. The only dilemma here is N3, N2 dilemma. Sometimes N2 is bigger. Sometimes both will be equal. It depending upon the problem. In some problems, this will work out. In some problem, this will work out. For this problem, which will work out, I don't know. But every time it will work. For every problem it is. But this is for some time, for some problems. For some problem it is. For some problem it is. We don't know exactly. Problem to problem it will differ. Problem to problem it will differ. Sometimes this will work, sometimes this will work. But this will work every time. This will work every time. So because of you got some clarity, some idea you got. If anyone don't know, please revise the notes. If anyone don't know, please revise the notes. I given lot of time also to revise. If anyone having some small doubt also, please refer the notes. You will get the more clarity. Right now I am checking. To this grammar, right? CLR1, LALR1, which is having, right? What about the state relation? To this problem, CLR1, LALR1, what is the relation? I am going to do it now. Can you see everyone? Everyone see, it's a very, very important question. It is a very, very important question. That is the reason I am covering. This will confuse you also, right? Most probably it will confuse you also. That is the reason I am doing this, right? So because of he is asking CLR1, LALR1, you have to construct automata for LR1 items. Let me check here how the LR1 item. S dash goes to dot S, comma dollar. LR1 item. So this is the look ahead symbol, right? Fine. S dash goes to dot S, comma dollar. Because of dot S, S possibilities all from grammar. Dot open bracket S closed bracket dot A. Because of it came from here, first half remaining. So dollar you have to write. So this is I0 state. So I'm not explaining total story to you because if I start explaining everything, so it is not a RIC course. RIC course is only for practice course, only for practice purpose, good problem practice purpose. If you study RIC, most probably questions will come from RIC only. Total my experience I'm using, and we are making the RIC course using my total experience. Mostly questions will come from RIC, right? So I'm not teaching everything, I'm teaching whatever problems needed. So I0 you done. Now see the next one. On this state, if you give S as input, I think if you give S as input only one person, you no need to write. Only one person is coming, you no need to write. Right? Only one person is coming, you no need to write. Right? But here, because of number of states, it is better to write. When the number of states question will come, it is better to write everything, right? So that you may not having any doubts. S dash goes to S dot comma dollar. It is I think I0, it is I1. It is I1. Now on the state S is over, let's go for On this state, if I give open bracket, what is the answer? If I give if I give A as input, it will goes to S goes to A dot, comma, dollar. I think this also, I do. You can give whatever input you like first. There is no objection at all. Now observe clearly. On the state, if I give open bracket, it will goes to S goes to open bracket dot S closure bracket, comma, dollar. That's okay. Because of dot S possibilities all. S goes to dot open bracket S closure bracket dot A. It is came from here first of remaining. So I think closure bracket will come. This is I3, but now you will get the clarity. Now listen, now you will get the clarity. Please listen this. On the state, if I give A as input, what it will do is, it will goes to S goes to A dot, it will goes to S goes to A dot, comma, closure bracket. So this is the, right, I think state number is 4, I4. But do you believe or not? Do you believe or not? Everyone observe. Do you believe or not? In the case of everyone observe, in the case of CLR1, if two states contain same production, if two states contain same production, differ by look ahead. If two states contain same production, differ by look ahead. Right? Remember everyone. If two states contain same production, differ by look ahead. They are two different states. In the case of CLR1, these two are two different states. But in the case of LALR1, these two are one state. Some people are asking, what is the difference between LALR1 and CLR1? In the case of CLR1, if two states differ by only look ahead, you have to separate it in the CLR1. In the LALR1, if two states differ by only look ahead, you have to make it as one state. So these two are two states in the CLR1, right? These two are one state in the LALR1. So you have to always look for this kind of thing. Any two states which contain same production differ by only look ahead. If you find out one incident also, then immediately you can say, oh, in the case of CLR1, these are 2. In the case of LALR1, these are 1. What is the LALR1? Minimized CLR1. Minimized CLR1, which is nothing but LALR1. Right? LALR1 also CLR1, but minimized CLR1, which is nothing but LALR1. So I2, I4 are two states in the case of CLR1. Those two are one state in the case of LALR1. So I think by seeing this incident, I can easily say, no need to proceed further also, not required. As Shiva is mentioned, right, LALR1 contain these many states, right, CLR1 contain these many states, no need to do also. At anywhere, if you find out this kind of behavior, two states differ by look ahead. CLR1, they are 2. LALR1, they are 1. You can stop. So CLR1 is more. CLR1 means N2 more. LALR1 means N3 less. So answer is N1 is equal to N3, right? Where N3 less than N2. I think this is the answer. B is the answer. For some problem, this is the answer. If at all nothing is mentioned, right, no grammar is given. See, depending upon grammar, answer will change. If no grammar is given, if you want to talk in general, you have to talk like this one. N1 is equal to N3. If no grammar is given, you have to write like this one. N1 is equal to N3, which is less than or equal to N2. This is the relation. In general, relation is this. So N2 may be more or equal to N3. If grammar is not given, this is the in general. In general, this is the relation. It's the in general relation. If grammar is given, either B or C, depending upon grammar. So to this problem, B is the answer. For some other problem, C is the answer. I hope everyone got it. Shiva, whatever you done is right, but you done the entire problem, really not required. You done the entire problem, really not required. Fine, is it okay? N1, N3 both are equal. N1, N3 both are equal. N2 is maybe more. may be equal to N3. Right? N2 is maybe more or equal to N3 depending upon problem. If nothing is mentioned, less than or equal to. If something is mentioned, either equal or less than. Someone is saying, if no RR, SR in LR1, then what about LR1? So that is a very standard statement, right? That is a very standard statement. So that is the reason powers are decreasing. That is the reason powers are decreasing. So after combining in the LALR1, some problems may come in, right? So suppose in that CLR1 don't have problem. After combining, which is known as LALR1, there may be a problem. That is the reason LALR1 power is a little bit decreased. LALR1 having little bit less states because of minimization, little bit less states, but the problem is, right, some conflicts are coming. Some conflicts are coming. Can we go ahead? So RR, right? So CLR1 don't have RR. After combining in the LALR1, you may get RR. CLR1 don't have SR. LALR1 also don't have SR. Every time problem will not come. CLR1 don't have RR. After combining, RR may come. Right? Because right, YAC parser is the right. What the YAC will do is, right, by comparing all the things, right, states also, conflicts also, YAC may be little better by comparing all, right, cost wise also. If you compare the cost wise also, conflicts wise also, right, maybe generally used parser is LALR1. Most generally used parser is LALR1. However, CLR1 is more powerful. Yeah. Can we move to next problem? Most generally used parser is LALR1. Problem is, right, less power. Problem is little less power comparing with CLR1. Little less power. Not completely less power, little less power comparing with CLR1. But right, advantage is little bit less cost also comparing with CLR1. Little bit less cost also comparing with CLR1. Yeah, we can move to the next problem. Yeah, can you see the next problem? See this? Consider the following grammar. This is the grammar. Consider the following grammar. This is the grammar. So he is asking, this grammar is LL0 or not, LL1 or not, LR0 or not, SLR1 or not, LALR1 or not, CLR1 or not. He is asking all. So because of he's asking all, superior is CLR1. So try CLR1. Whenever all are asking, try CLR1. Because he is the superior one. Suppose assume that CLR1 itself is not working. So definitely others don't work. So whenever all are asking, try CLR1. All are asked, try CLR1. So start. Consider the following grammar. S goes to X1, X goes to A1, B, R2, A goes to 2, B goes to A. Right? Consider the following grammar. One grammar is given. LL0, LL1, LR0, SLR1, LALR1, CLR1. All are asking means try CLR1. All are asking means try CLR1. Right? I am trying CLR1. I am trying CLR1. Can you see one time? S dash goes to dot S comma dollar. Because of dot S possibilities, S goes to dot X1. So dollar. S dash goes to dot S comma dollar. Because of dot S dash goes to dot S comma dollar. Because of dot S, all S possibilities. I think S having only one possibility. I written. Because of dot X, all X possibilities. From where it came here, look at are 1. Next one, because of dot A, all A possibilities. From where it came here, first half remaining, so 1. So B will not come because nowhere first place B there. After dot, nowhere, after dot, nowhere B is there immediately. So B will not come. So this is I0. This is I0. Be careful. This is I0. Okay, that's fine. That's fine. Just I want to ask you one small line. Please be careful, everyone. Please be careful, everyone. Everyone be careful. And one more thing is, instead of applying everyone, please apply that input which will give reduction immediately, because to get the conflict to SR, reduce required. RR, reduce required. So to get the conflict, reduce compulsory. So first to try, right, those people who will give reduction immediately. So I can try the total diagram, but it will take a lot of time. Whenever they are asking everything, if you keep on trying everything, everyone can solve this problem. But how much time you will finish, that matters. How much time you are going to finish this problem, that matter. If you solve this problem by taking 10 minutes, no use. If you can solve this problem by taking 1 or 2 minutes, you are going to be excellent. Remember, to get the conflict, SR are required, RR required, means reduce required. Please concentrate first on the reduce entries. Who will give reduce? I think if I give 2 as input, X goes to 2 dot will come, comma, right, comma 1. Okay, in the similar way, A goes to 2 dot will come. That is also comma 1. So these two people. So remember, these two people are reduced. These two people are reduced. I think it's the correct time to ask you. Let us assume that it is the state number, some number 1. If you go to the state number 1, if you go to state number 1, if you observe clearly, state number 1, at 1, this production also completed, this production also completed. So what is the production number? It's a 1 here, it's a 2 here, it's a 3 here, it's a 4 here, it's a 5 here. If you see in the I1 state at 1, production number X goes to 2, means 3. So third production is completed. And at the place of 1, I think fourth production also, right? Fourth production also. So this is going to be R3, third production reduced. This is going to be R4, fourth production reduced. This is called RR conflict. This is going to be RR conflict. Remember everyone, I am not teaching parsers here. I am solving problems. I am not teaching parsers here. I am solving the problem. Please be careful. So whenever all are asking, try CLR1. In the CLR1 also, if you want to complete fast, give reduction. Give those inputs first, which will give reduction immediately. See, this production is completed. This production also completed. 2 productions are completed. What is the production number? Production number 3 completed. So R3. Where you keep R3? At the look ahead place. Production number 4 also completed. R4. Where will you keep? Look ahead place 1. At 1 place, R3 also there, R4 also there in the state number 1. Sir, how can you give input to 2 directly? Yeah, I can give one by one. At the end of the day, I have to give all inputs. Okay. But it will take 10 minutes. So solve the problem as soon as possible. It is one of the nice problem. This problem you can handle means most of the problems you can handle. So finally, given grammar is because of RR conflict. Given grammar is not SLR1. Remember? Sorry, given grammar is not CLR1. CLR1 itself fail means there is no chance of he will pass. There is no chance of he will pass. There is no chance of he will pass because CLR1 is superior among all. CLR1 is superior among all. Answer is right. So no one. Answer is none. Answer is none. Answer is none. Let me know if anyone having any objections. Ready, sir? I have some objection. Please let me know. All gone. All gone. CLR1 gone means all gone. CLR1 gone means all gone. Let me know. Anyone having any issue. Remember, I am not teaching parsers here. I am teaching complex problems. This problem may come in the exam. This problem may come in the exam or similar problem. More productions he will give. See this one. More productions he will give. More parsers also he will give. It is one of the trick he is playing in the exam. More productions he will give. More parsers also he will give. His only condition is, his only intention is this. Those people who don't have common sense. So what they will do is every parser they will check. Finally, they will give answer, no doubt. Right? Those people who don't have common sense, na? So grammar is big. So many parsers also have to verify. Common sense, right? Those people who don't have common sense, every parser they will check. 10 minutes they will take. They will give finally correct answer. But interesting thing is, in the 10 minutes, you could have solved 5 problems. You are solving 1 problem only. You are gone. So these kind of problems you have to handle like this. All are asking, try CLR1. All are asking, try CLR1. And one more, right? So then which input I have to apply? One blind idea is apply every possible input. If you apply every possible input, it will take a lot of time. But one thing I know, without reduce, conflict will not come. So concentrate on those people who will give reduction immediately. If I give 2 as input, reduction coming immediately. So 2 reduce there. But in the CLR1, where will you keep reduce entry? Look ahead symbol, please. So R3 at 1, R4 also at 1. In the row number 1, at a column number 1, there is a R3, R4, RR conflict. So given grammar is not CLR1. It is not CLR1 means it is not LALR1, it is not SLR1, it is not LR0, it is not LL1, it is not LL0. There is no practical parser which is LL0. LL0 is wastage of time, nothing there. No parser like LL0, but LR0 is there. In the case of LL parser, that one means at a time how many symbols you are reading. But in the case of the LR0, right, that 0 means different meaning. Here 0 means how many symbols you are reading at a time. 0 symbols you are reading at a time, there is no meaning. But in the LR0, the 0 is different. Right? The 0 is different. So meanings are different. That is the reason LL0 not possible, because without seeing any input, what is the meaning of doing parsing? You have to read one by one symbol. But in the LR0, that 0 is different meaning. Right. Perfect. Perfect. Can we go next? It means backtracking. It's not like that. Not like that. LR0, that 0 indicates. LR0, that 0 indicate. LR0, that 0 indicate where are you keeping reduce entries. In the LR0 parser, I don't care where I am keeping. Total action part, I will keep reduce entries. In the LR0, when you are writing reduce entries, where will you write reduce entries? LR0 saying, I don't care where I am writing. So I will write the reduce entries in the total action part. Total action part, I will write reduce entries. But in the case of CLR1, reduce entries, you will write only look ahead place. See, I written R3 only at one column. I written R4 only at one column. But in the LR0, I will write R3 total row, I will write R3. R4 also I will write total row, I will write R4. right? In the LR0, total row you write. In the CLR1, only look ahead place I will write the reduce. In the LR0, everywhere I will write. That is the meaning of that line. Right? Be careful. Be careful. Meanings are different. So LL0 practically not there, but LR0 there. But what the 0 means? In the LL0, 0 means how many symbols at a time you are reading. In the LR0, right? 0 means reduce entries, where are you writing? In the LR0, blindly I will write everywhere. That's the reason it is LR0. If you okay, I can move to the next problem. Please let me know, are you okay or not? Please let me know, are you okay or not? Make it fast. No. Make it fast. Bro, make it fast. Can we go ahead? Let's move to next problem. Let's move to next problem. Let's move to next problem. What is the output of this? Can you try this? Can you try this problem? Try this problem. It is a nice problem. Am I audible? Am I audible? Can I give answer? Can I give answer? Right. Now see everyone. This kind of problems, you may use the keyword top down, bottom up, something like that. Don't think much. Listen, don't think much. Whenever this kind of problem is given, don't think much. Top down, bottom up, don't think much. Remember, see this one. After these two people, only do the semantic action. Wherever semantic action is there, do that place only. Wherever semantic action is there, do that place. What is the meaning? After these two, semantic action. What is the meaning of after these two? Means after this production. See, at the end of the production, semantic action. At the end of the production, semantic action. At the end of the production, see, after production, semantic action. Within the brackets means semantic action. At the end of the production, semantic action. At the end of the production, semantic action. At the end of the production, semantic action. So let's start here. Let's start here. So first of all, generate the tree first. AAA DBC. AAA DBC. Let's check. S goes to AS. Okay. I want AAA. I want AAA. Again, S goes to AS. I think so. S goes to AB. I think this is going to be single A. This is also going to be single A. This is also going to be single A. Until now, fine. B goes to DB. So D also came. B goes to BC. C goes to C. C goes to C. So I think all total string is came. Total string came. Remember, after production over, then only semantic action. After production over, then only semantic action. Then how you do? Do from bottom left side. Production over, then only semantic action. Remember everyone, this production is over. Here semantic action will execute. Right? See this one. After this production, there is a semantic action. Here 3 will be printed. So you have to start from down, from left side. So I think A goes to A, production is over. Here semantic action. So 3 will be printed first. So first 3. Okay. Then I think this is completed. Semantic action also you done. It's okay. Now see this one. You two complete. Remember everyone. S is over. This production is over. Then only the semantic action. So this one will come after completion. After completion only. Right? This S also over. Then I can print this one. Right? So because if it is not over, I cannot print now. S goes to AS. I think first this. I think here again. So 3 will be printed. So this also completed. Come here. S goes to AB. So first this one. So remember S goes to AB means after AB over, then semantic action 2 will be printed. S goes to AS over, then S after this, I think 1 will be printed. Right? Because of not over, I am going further. Because of this, again 3 will be printed. So I think now I went to the B. B goes to DB. Remember, B goes to DB. D over, see, remember D over, but there is no B goes to D production. So DB is one production. So B goes to DB. This is over, then go here. B goes to BC, right? I think B goes to B, there is no production, right? So I think B over, then go to the C. C goes to C. So this is. Can you help me? Can you help me? C goes to C. C goes to C means what is the number? C goes to C means 6 will be printed. 6 will be printed. So 6. Now I think this is completed. Then BC completed. Then B goes to BC. What is the number? B goes to BC? 4. 4 will be printed. 4 will be printed. Next one, B goes to DB. B goes to DB. What is the number? 5 will be printed. 5 will be printed. S goes to AB. What is the number? 2 will be printed. Next one, S goes to AS. What will be printed? 1 will be printed. S goes to AS. So 1 will be printed. Right? Check now. So 333 64 52 11. Remember left to right you have to print. After production over, then only semantic action. After production over, then only see this one. So whenever this also over, so S goes to AS over, then semantic action. Next one, S goes to AS over, then semantic action. Then S goes to AB over, then semantic action 2. Next one, A goes to B, then semantic action 3. B goes to DB, then semantic action 5. B goes to BC, then semantic action 4. C goes to C, then semantic action 6. Right? I hope people got. Remember, I am not teaching anything here. Again and again I am saying. I am not teaching anything here. Just I am solving problems. Most probably this also expected in the exam. 333, I think 333, not so many, not 4 threes. 333, 6452, 11, 11. How 4 ones bhaiya? How 4 threes bhaiya? How 4 ones bhaiya? 2 ones only. S goes to AS, S goes to AS only 2 times. S goes to AS, S goes to AS 2 times. 2 ones only will come. A goes to A goes to A goes to A 3 times. So 3 threes only will come. How 4 threes? How 4 threes? How 4 twos? S goes to AS only 2 times. Shiva, please let me know. 333 exactly. Shiva, let me know how you got. Make it fast. How you got? Shiva, let me know how you got. Let me know how you got. If sorry, that's perfect. I thought some other way may be there. I thought some other way. Some students are asking, sir, for this one, if at all, multiple parse trees, then what is the answer? Multiple parse trees, then multiple answers. If anyone say, sir, for this problem, if at all multiple parse trees, then multiple answers. Multiple parse trees means multiple answers. If anyone say, suppose to this input, multiple trees possible, then what I will do? So that is their responsibility. They have to give unambiguous grammar. They have to give unambiguous grammar. Right? They have to give unambiguous grammar. Try to remember. They have to give unambiguous grammar. If multiple trees are there, multiple answers will come. It is not our mistake. Yeah, there may be. There may be. So here print 1 is there. Here print 1. There may be print 2. There may be print 11. It's up to them. Right? Whenever you say semantic action, you can write whatever you want. Right? It may be 0, 1, 1. Print 1, print 0, 1, 1. You can print 0, 1, 1 also. Print 1 first followed by 0, 1, 1. Print 1 first followed by 0, 1, 1. Like that you will print. Multiple printfs also can be there. One production can have multiple semantic action. Maybe 10 printfs also can be there. No, you have to print all. Not multiple answers. You have to print all. In the place of printing 1, you will print the 1, 0, 1, 1. Not multiple answers, madam. In the place of printing 1, you will print the print 1, 0, 1, 1. Both printf you have to print. If one production contains multiple printf, how many printfs are there? Print all of them. There is no if and else there. There is no if and else. Yeah, good question. Good question. Thank you. Thank you, Ella. Thank you so much. Let's move to next problem. Let's move to next problem. Consider the following grammar. One grammar is given. What is first of A? What is follow of A? Can you finish it off? It is a very simple problem. It is a basic thing in compiler. Compiler, you will be comfortable in compiler if you know how to find out first, how to find out follow. If you know how to find out first, how to find out follow, you will be comfortable. How to find out first, how to find out follow, if you know, you will be comfortable. So first and follow, if you know compiler, half of the compiler you can handle. First and follow if you can handle, half of the compiler you can handle. So please be careful. Your starting symbol is A. Your starting symbol A. So remember, follow of start symbol, minimum dollar. Only start symbol. Because of A is a start symbol, because of A is a start symbol, right? Minimum dollar. So dollar already came, right? Dollar already came. But so to calculate the follow, there may be a requirement of first. Let's complete the first. Let's complete first. Can you see how to find out first? If you want to find out first of any person, first go to the production left side. Where is the A? Find out. First of someone you want to find out? Yes. Go to the production left side. Where is the A? Find out. Left side A, only one place. Okay. So first of A is equal to first of this. So first of B A dash, which is equal to first of B. Let's go to first of B. How to get the first of B? Same. If you want to find out first of any person, go left hand side of the production. Where is B? Here. So first of B is equal to first of this, first of this. So first of B is equal to first of CB dash and first of epsilon. So epsilon. Now I think everyone know first of CB dash means, right? First of CB dash means first of C. The effect of here is first of C. Let's check. First of any variable is, right? So go left hand side of the production. Where is the C? Find out. First of C is equal to first of this, first of this. So first of the first person is plus. So first of the second person is ID. ID means identifier. So overall if you observe, right? You got the plus also, ID also, okay? Right? First of CB dash means first of C, you got plus and ID, that is fine. Right? Now see this one. I think you all are doing because of first of B. See this one. Because of first of B, you are doing this entire work. This entire work you are doing because of first of B. So first of B contain plus also, ID also, epsilon also. Remember, first of B you got 3 people. So means because of this person you are doing. So finally this person contain, right, plus also, ID also, epsilon. Because of is epsilon possible, you have to go here also. So epsilon compensation is go further. So first of A dash also. First of A dash means same as usual. Go left hand side of the production. Where is A dash? Find out. First of A dash is first of this, first of this. First of this is going to be star. First of this one is epsilon. Because of epsilon, keep this one epsilon, go further. Further no one, further no one. Lastly also epsilon coming, please keep as it is. So the final answer is going to be plus also, ID also, and a star also, epsilon also. This is first of A. You may be confused, I can understand. You may be confused, I can understand. But remember, I am not teaching compiler here. I am just solving toughest problems. This is the compiler design RIC course. This is the compiler design RIC course which contain tough problem. I am sure if you follow all the classes, whatever I am saying, you will get the full marks. You will get the full marks, right? But make sure you don't do any mistake. Make sure you don't by heart. Plus ID star epsilon. So first of A is plus ID star epsilon. I will recheck once again. First of A. First of A is first of BA dash. Means first of B. First of B is equal to first of CB dash epsilon. First of CB dash means first of C. First of C is a plus and ID, no problem. So finally, plus ID epsilon. That is the first of B. But because of B becomes epsilon, you have to go further also. Cancel epsilon, first of A dash. First of A dash is, I think, star and epsilon. Because of epsilon, keep A dash plus epsilon, go further. No one there. So then I think you can stop and you can write epsilon. So finally, plus star ID epsilon. That is the first of A. I think follow is going to be interesting. Let's check. Follow is going to be interesting. Let's check. So if you want to find out follow of any person, if he is a start symbol, write the dollar first. That is okay. Now some people are asking then how to proceed follow further. Remember how to proceed follow further. Everyone understand? Follow if you want to find out. Go right hand side of the production. Where is a follow of A? Where is A? Write down. Go right hand side of the production. Where is A? Right hand side. Where is A? Right? I think A, if you observe, I think only one place. Follow of A is, right? I think A only one place. Follow of A is first of remaining D. Right hand side A is there only one place. Right hand side A is there only one place. Follow of A is because of start symbol dollar. Go right hand side where is the A? A only one place is there. So follow of A is right. I think first of D, which is D. I think dollar D. I'm thinking everyone got it. Let me know. Let me check the your answers. Let me check your answers. Let me check your answer. So, right, first is going to be plus ID star epsilon. Second is going to be dollar and D. Dollar and D. Let me know what the answer for. Anyone having any objection? Anyone having any objection? Please let me know. Small doubt also there. Please let me know. Anyone having any objection? Please let me know. Can we go to next problem? If you agree, I can move to the next problem. Can we move to next problem? Today's problems are excellent problems. Today's problems are excellent problem. Can we move to next? Can we move to next? Today's problems are excellent problems. Can we move to next? Bro, can we move to next? Hello? Can we move? Yeah, let's move to next. If anyone done small mistake also, please rectify because they are not easy problems. They are really tough problem. They are really tough problem. To me, they are very easy because many times I done. To me, they are very easy because many times I done. To you, definitely they are very tough. Yeah, can you concentrate this problem? Problem number 121. Problem number 121. Can you go ahead? It is a very interesting problem. This is going to be very interesting problem. So one grammar is given, is asking, right, S1. LL1 can parse all strings that are generated using grammar G. S2 saying that LR1 can parse all strings that are generated using grammar G. Indirectly, they want to say above grammar is LL1, that is a S1. Above grammar is LR1, that is S2. Indirectly, they are saying above grammar LL1, above grammar LR1. So you have to identify and you have to solve this issue. It's a very interesting problem. Can you check? Yeah, can you verify? Can you verify what is the answer? What is the answer? I think everyone know. If you observe clearly this problem, right? See this one. If you observe clearly this problem, from this grammar, if I want to generate input string, simply see. If I want to generate, see this one. S goes to F. F goes to C. It is a one way. S goes to H. H goes to C. One more way. So what I mean to say is, to generate the string C, we have two parse trees. It is a ambiguous grammar. This is ambiguous grammar. So remember, if any grammar is ambiguous, it cannot be LL1, it cannot be LR1. If any grammar is ambiguous grammar, it cannot be LL1, it cannot be LR1. Try to understand. In GATE examination, I am saying again and again, common sense is more important. In GATE examination, very, very important thing I want to say to you. Common sense is very, very important. Common sense is very, very important. In GATE examination, common sense is very, very important. So this is such a nice problem. This is such a nice problem. This grammar is LL1. This grammar is LR1. Interesting thing is, given grammar is ambiguous grammar. Given grammar is ambiguous grammar. Ambiguous grammar never be LL1. Ambiguous grammar never be LR1. So answer is neither S1 nor S2. Answer is ambiguous is the reason for this. Ambiguous is the reason for this. Right? Tomorrow onwards, right? Compiler classes approximately, I think, in my opinion, 5 to 10 classes are there. Compiler classes, right? 5 to 10 classes are there. 5 to 10. Already inside the EPT, there are 100 problems are approximately, right? So yesterday happened, today happened, and 5 to 10 more classes will be there, depending upon, right, how much tough problems I am able to find out. So don't miss it. Tomorrow onwards we will try 8 to 10. Tomorrow onwards we will try 8 to 10. 8 to 10 we will try. Yeah, let's go to next problem. Very interesting problem this also. Can you try this? Consider two binary operators. Up arrow, down arrow. With the precedence, right? With the precedence of operator down arrow being lower than that of operator up arrow. So simply two operator. Up arrow, down arrow. There are two operators. If you see, with the precedence of operator down is lower than that of operator up having more priority. You want to say that. The precedence of operator down being lower than that of the operator up means operator up having more priority. You want to say that. Okay, fine. This is the priority. Precedence means priority. And is he mentioned anything about associativity? Can you see the next one? Operator up is right associative, while operator down is left associative. So I think down is left associative, right? So I think up is going to be right associative. Please remember this also. So priority wise, up one is bigger, but if you see the associativity, up one is the right associativity, down one is the left associativity. Please be careful. If you really comfortable, see the expression. Everyone listen. This is such a nice problem. It is such a nice problem. Can you see this one? Everyone, very interesting. So up is the right associativity, down is the left associativity. So up is the more priority than down. So if you observe clearly, see the answer. To these three purpose, remember always fighting is with neighbors only. You no need to compare the right left one, right one. You no need to compare. Every person fighting is neighbors only. My competitors are my neighbors. Your competitors are your neighbors. So remember, you no need to compare you and US person. You compare you and Indian. One more Indian you compare. Your competitor is not, right, some other country person. Your competitor is your country people. Your competitor is your country people. So same thing here. So 3 is right, 3 fighting if you observe neighbors only. Neighbors. What are the neighbor? So to this 3 if you observe, neighbor 7 is saying that, so 3 is mine, so that 7 down 3 will be done. This 7 is saying that 3 is mine, so that 7 down 3 will be done. But this 4 is saying that 3 is mine, so 3 right, up arrow 4 will be done. So 3 purpose, left side person 7 fighting, right side person 4 also fighting. Whoever having highest priority, they will take. I think comparing the down and up having more priority. So up having more priority. Remember, 3 will go with up. So these two will be done. But if you observe clearly, this 4 purpose, one more person also fighting. So finally 3 came with 4. Okay. But what about 4? 4 will come or not? Let's check. 4 is saying that my left is up arrow, right also up arrow. Both are two up arrow. See, up arrow having right to left associativity. So remember, this 4 will go with the right person because right to left associativity. Next one, this three purpose, left 4 also fighting, right 2 also fighting. Who is the highest priority? Up 1 only. So finally, this will be done first. So if you start left hand side, just compare neighbors according to priorities and associativity, please take care. Finally, according to the given condition, right? Up arrow having more priority, but 2 up arrows are there. Which up arrow should be done first? Up arrow having right to left associativity, so right should be done. So 4 power 3 should be done first. Afterwards, next up arrow with that answer. 3 up arrow, that answer. Now up arrows are all done. Now let's see down arrows. If you see the down arrow, 2 down arrows are there. Down arrow having left to right associative, so left should be done. So 7 down arrow this. Lastly, this answer down arrow 2. So this is the number 1, this is the number 2, this is the number 3, this is the number 4. Right? I think now you got the clarity. Now go and see the, right? Remember, in the entire tree, 4 up arrow 3 will be done first. 4 up arrow 3. See the tree. They are given the tree. Remember, in the tree, right, bottom people will be done first. In the tree, always remember, 3 bottom people will be done. Remember, 4 power 3. 4 up arrow 3 should be done first. Can you see in the which tree? 4 up arrow 3. Here see, 4 up arrow 3. 4 is somewhere. Remember, first one is 4 up arrow 3. I think this is not the answer. 4 up arrow 3. It look like answer. Down people will be done first. 4 up arrow 3. 4 up arrow. Remember. 3 up arrow 4 is different. 4 up arrow 3 different. It may be, I think, divide operator. It may be power operator. You cannot change 3 power 4, 4 power 3. You cannot change. It look like same but not same. It look like same but not same. 3 power 4 different, 4 power 3 different. So this is also not. So I think directly I can say B is the answer, but anyhow, I will do cross checking further. If B is correct, it should correct further also. What are the further? I think 4 power 3 done. 4 power 3 done. Assume this is 1 you got. 4 power 3 you done. You got answer is 1. Next one is going to be 3 power 1. 3 power 1. See, 3 power 1 exactly. Assume it is 2. Next one, 7 down 2. 7 down 2. Yes. Lastly, 3 down 2. Perfect. I think B is the answer. Let me know your opinions. B is the answer. It's a nice way of asking question. So if you okay, we can move to the next problem. You may expect this kind of question in the exam. Yes, true. You can expect this kind of question once. In exam, most of the things are common sense only. In exam, most of the things are common sense only. Most of the things are common sense only. I'm again and again I'm repeating, most of the things in the exam common sense only. Common sense. Do you know basics or not? Do you have common sense or not? Do you know basics or not? Do you have common sense or not? Yeah, can you try this problem also? Can you try this problem also? Let G be the CFG, I be the number of leftmost derivations, R be the number of rightmost derivation. Leftmost derivations is L maybe, that may be L, okay. Rightmost derivations is R, that is okay. Let P the number of parse trees, okay, that is also okay. So see this one, parse trees, P. Leftmost derivations, let I be the number of leftmost derivations. R be the number of rightmost derivations. What is the relation between all? What is the relation between all? Remember everyone, remember. One leftmost derivation tree there means one rightmost derivation tree also there. One leftmost derivation tree there means one rightmost derivation tree also there. Right? Two leftmost derivation trees there means two rightmost derivations are there, which are nothing but two parse trees. In my opinion, they all are trees only. Let L be the number of leftmost derivation trees. See, I think it may be common line. It may be common trees. L is the leftmost derivation trees. R is the number of rightmost derivation trees. P is the number of parse trees. They all are trees only. L is the leftmost derivation trees. R is the rightmost derivation trees. P is the number of parse trees. Remember, three leftmost derivation trees. Definitely three rightmost. Definitely three parse trees. Totally all three will be equal. Please be careful. Fine, all three will be equal. Fine. All three will be equal. Remember, they are derivation trees. Derivations and trees I cannot compare. Derivation trees, all are trees. All are trees. See, three leftmost means three rightmost. Means three parse trees. Three leftmost means three rightmost. Means three parse trees. One leftmost means one rightmost. Means one parse tree. You maybe say that one leftmost, one rightmost. Totally two. No. One tree only. Left-handers will count in their account. Right-handers will count in their account. There is a one tree. Left-hander will give always importance to left side. Right-hander will give always importance to right side. At the end of the day, one tree, which is nothing but unambiguous grammar. For unambiguous grammar, left-hander will draw with the left hand side. Right-handers will draw with the right-handers. At the end of the day, one tree only. If there are multiple leftmost derivation trees, there are multiple rightmost derivation trees, then multiple parse trees. Okay, na? Bro, what do you say? Make it fast. 5 leftmost, then 5 rightmost, then 5 parse trees. 1 leftmost, then 1 rightmost, then means 1 parse tree. If only one left-hander will think that leftmost derivation tree. Right-hander will think that rightmost derivation tree. But overall, one derivation tree only. Overall, one derivation tree only. Answer is L is equal to P is equal to R. Perfect. Perfect then. Let's move to next problem. Yeah, can you see this also? Can you see this also? It will trouble you. Please be careful. Can you see this? It is a very interesting problem. It is a very interesting problem. So if you observe clearly in this problem, if you observe clearly, I loop, J loop. Do you believe or not? Do you believe or not? I loop, J loop. I loop, J loop. So conditions, it is one. I loop, J loop, okay. Condition you written J modulo 2. Condition you written J modulo 2. You should know total terminology. You should know total terminology. Total terminology you should know. Total terminology. So code optimization chapter, total terminology you should know. Code optimization chapter, total terminology you should know. Yeah. What is the answer you are thinking? Most probably, I think you people are given answer also. Let's check. Let's check your answer. Let's check your answer. So just I want to ask you one thing. Observe everyone. Mostly you are given your answer may be correct also. Just observe one thing. If you observe clearly, see inside. if you observe clearly here, you are doing each j value, you are doing 5 into I. Each j value you are doing 5 into I. See, j value 0, you will do 5 into I. J value 2, you will do 5 into I. J value 4, you will do 5 into I. Means what I want to say is, something which is not changing again and again, you are doing again and again. See, j changing, why are you calculating 5 into I? So what I mean to say is, this one you could have kept here. You could have written here, see, t is equal to 5 into I. You could have written here. So you could have moved it. This is the one which is not varying. Each j value, how 5 into I will change. So this is called as inside loop. There is a something which is not variant. Inside the loop, there is a something which is not variant. That is called loop invariant. Inside loop, there is a one person who is not changing. So why you return? So the best thing is keep this person outside so that you can do only one time. So I is equal to 0, t is equal to 5 into I, come inside. X is equal to x plus 4 into j plus t. So the code contain loop invariant computation. True. This is true. There is a scope of common sub-expression elimination. If you observe clearly, 4 into j 2 times. Why are you doing 2 times? Common, right? Common sub-expression elimination. Do one time, reuse it. Do one time, reuse it. How? Let's see this one. It is a T1 assume. It is a T1. So here you can write. T2 is equal to 4 into j. So here you can keep T2. So here also you can keep T2. So, right, no need to do 4 into j 2 times. One time enough. There is a scope of common sub-expression elimination. Some expression which is common, you can eliminate. There is a scope of strength reduction in this problem. I think so. Because 4 into j multiplication you are using, instead of that, j plus replace costly operator by cheaper cost operator. Strength reduction also possible. There is no dead code elimination. What is the meaning? From the starting, every statement is reachable. From the starting, every statement reachable. So there is a scope of dead code elimination. That is wrong. It's a very, very interesting problem. It's a very, very interesting problem. It's a very, very interesting problem. Which one of the following is false? There is a scope of dead code elimination in this code. That is the mistake. Fine, perfect. Yeah, I think I am stopping here. In tomorrow's class, we'll start from 125. In tomorrow's class, we'll start from 125. Today we done very good questions. Someone is saying that j, yeah, that is also right. So that is not you are replacing by costly operator. It's I think you are doing left shift. Yeah, that is also. Replace multiplication by 4 by 2 left shift. That is also correct. Replace costly operator by, right, less cost operator. Multiplication by 4, which is nothing but 2 left shift, or 3 times adding. That is also okay. Yeah, D is false. Yeah, of course, he is asking false. D is false. A, B, C true. Perfect. Right? Question number 124 we done. In the next class, we will see, right, remaining problems. If anyone is not joined the RIC course, I request you, please join. RIC course, if anyone is not joined, please join. I request you. 80% offer is going on. Very good discount going on. Please use it. Very good discount going on. Please use it. Yeah, last night you promised 20, but good problems. What can I do? Good problems, right? Good problems. That is the reason it is taken some time, right? Perfect. Tomorrow we'll try. Tomorrow 8 to 10. Tomorrow 8 to 10. It's almost time is now 10:10. That is the reason. Tomorrow, right? We'll try. Chalo then. Chalo. Thanks everyone. Good night. Thanks everyone. Tomorrow onwards class is in EPT. Okay, fine. Thanks everyone.